Hello, everybody. Before starting my presentation, let me express my gratitude to the IPCMC team for giving us the opportunity to participate in this e-conference. As you know, the topic of our study was the cost comparison of reinforced concrete structures designed according to Turkish and European Earth Code. Firstly, I will give some brief information about our study's content. The study is made of 5 chapters. History and development of seismic codes was discussed in the first chapter. After that, the comparison of codes in manner of element design, structural loads, ductility, and earthquake loads were explained. These rules were implemented in third chapter where an example project were discussed, and at the end results and conclusions were given. Due to time limitation, we won't cover the history of seismic code development. Different countries around the world use different regulations for structural design. Therefore, the same structure built in different places will give different results. So the costs will be different from each other. One of the most important regulations used in structural design are the seismic codes. In this study, the cost of the building designed according to both Turkish and European codes are compared and cost effectiveness is measured. The objective of this study is to identify which code provides a more economically feasible design. As we know, in order to design a structure, every element is designed and controlled separately. For columns, beams, shear walls, and slab designs, European and Turkish code have provided different criteria starting from minimum dimensions, minimum and maximum reinforcement ratio, maximum bearing loads, etc. All these details and differences are given in this study. For example, minimum column dimensions according to European codes is 200 millimeters, while in Turkish code is 250 millimeters. Now I will try to explain one of the most important parts of this study. The earthquake load assignment is the criteria that differs every seismic code. As the peak ground acceleration of the earthquake affecting the structure is one of the most important elements to obtain the earthquake loads, we managed to provide response spectrum plots with the same PGA. The PGA value we used was about 0.38 G. After defining the spectrum, we can see that Eurocode provides larger earthquake loads, which lead to higher sections, therefore higher cost. In order to see the reactions of the structure and perform the design, all types of loads must be combined with proper coefficients. Also, in this manner, design codes differ from each other. For example, in the second combination, which is the most fundamental combination to design the structural elements, we see difference in two codes. For the Turkish code gives a less economical solution, and as for the earthquake load combinations, the coefficients are the same. Now I will start with the part of the example project. The reason we did the project was to implement the rules in reality. We chose a structure built in Turkey, Istanbul, and Montenegro, It's a 7-floor high structure made of reinforced concrete. The design was done using ETABS software according to Turkish and European rules. Other informations such as dimensions, the purpose of the structure, material strength, PGA magnitude, elements dimensions are given in the table. And now is the most important part of the study. Firstly, we will discuss the bill of quantities. As seen in the table, bill of quantities in tons and cubic meters were calculated according to both codes. For columns and beams, Turkish code required larger quantities, as you can see, larger quantities of concrete, as you can see in the table, while for slabs and shear walls, the quantity is same. The rebar results also show that Turkish code requires higher quantity. Although the bill quantity showed that Eurocode gives a more economical solution, the prices in Turkey made the difference. For example, as seen in the table, the price of concrete in Turkey is 2.5 times cheaper than in Europe, while the rebar is 45% cheaper in Turkey. The material prices are taken from competent authorities in both countries, and they were used to estimate the cost of the building. Even though the Eurocode has less amount of concrete and rebar steel, the price for building the object is significantly higher in Europe. Therefore, the price for the same building in Europe is estimated to be about 118,000 euros, while in Turkey it's about 700 euros, and it makes Turkey 41% cheaper. To sum up, results of example project have shown that structure with exactly same properties under seismic laws with the same magnitude, constructed in different areas, demand different quantities of materials due to different regulation and different prices in places where they are constructed. I want to thank you for your attention. Stay good and healthy.